Hey folks, today's topic, graphing trig functions, part 1. Next time we're going to do graphing trig functions, part 2. So what we're doing here is we are taking our unit circle. We're taking now let's just do sine first. Let's talk about sine. So we're going to take the sine values as we rotate around the unit circle. So our first sine value, so when x is 0, that corresponds to 0 degrees or 0 radians, whatever. I'll go with radians, I guess. 0 radians. And then as we move out to the next tick mark, that's going to represent 90 degrees. The next tick mark, because this is set to 2 pi, all right, each one of these tick marks, so if this is 2 pi, this would be half pi. Sorry, this would be pi, and then this would be half pi. So each one of these tick marks is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 reduces to be 2 pi. And what we're doing is we're looking at in this case, sine. We're looking at the heights. We're looking at the y values as we rotate around the unit circle, and we're plotting those as a point. So let's look at, I've got a little program here that I stole from somebody. So I'm going to restart it. This is what happens. They're going to start with rotations around the unit circle. And the height, because we're doing sine, the height of the function corresponds to the point. So as we rotate around, you can see they've done 7 rotations, 8 rotations. Oh no, sorry, these are rotations of pi. So right now they've done 6 full rotations. Anyway, but this is what the sine curve looks like, because as we rotate around, when we start at 0, we're at a height of 0, and then it goes up and down and up and down. Anyway, so that's what the idea here. We're going to try to take the sine curve, the sine values, around the unit circle, and we're going to convert those into coordinate points in the coordinate plane. So what does that look like? Well, I've got little unit circles up here that we can use as reference as we rotate around. So let's start. We're going to do sine first. So this corresponds to 0 radians. So 0 radians over here is right there. What's the sine value there? Well, that's the point 1 comma 0. So it has a sine value. It has a y value of 0. Then we are going to rotate until we get up here. That, remember, each one of these is going to represent pi over 2, because I've already labeled these as 2 pi. So as I rotate around, what happens, I get these triangles, and look what's happening. Remember, we're doing sine, so I'm looking at the heights. What's happening to the heights of these triangles? They're getting taller and taller and taller until I get to this spot, which is the point 0, 1. And 0, 1 has a y value of 1. So all those triangles had y values, sine values, that were getting taller, taller, taller. Now, as I rotate around to the next 90, what's happening to the heights of these triangles? Maybe I can zoom in a little bit more. What's happening to the heights of these triangles? They're getting smaller, 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 until we get to this location, this point, which is negative 1, 0. Now remember, we're talking about sine, so I care about the y value. So what happened to these heights? They were at 1, then the heights got smaller and smaller and smaller until they got to 0. Then we're going to rotate again. What's happening to the heights of these triangles as I pick different angles in the third quadrant? The heights are getting bigger, but they're getting bigger in the negative direction. This is the point 0, negative 1, until they reach a height of negative 1. And then my triangles again are going to get, their height is going to get closer and closer and closer to 0. Technically, they're getting larger, but in my head, they're getting smaller from the negative side, so until we get to 0. This is what we call one period of the sine curve. That's one cycle. We call this a periodic function, because guess what's going to happen when I go around the second time and the third time and the fourth time and the fifth time, blah, 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 over and over? I'm going to continue to get the same values. As I rotate to 2 pi, here I am at 2 pi, and I start to rotate around to 4 pi, I'm going to then reach a height, my values are going to get higher and higher and higher until I reach a height of 1. Then my y values, my sine values, are going to get smaller, smaller, smaller till I reach a height of 0. Smaller, smaller, smaller until I reach a height of -1. And then larger, larger, larger until I reach a height of 0. Now, you can probably figure out that if we kept going, right, this would just continually repeat. And that's what that video was showing. It was just showing how the graph goes over and over and over and over again. So this is what we call the sine curve, the sine function, sine wave, most of the time is what people call it, especially those of you who love your physics. Sine waves show up quite a bit in physics. Electronics, probably is that the biggest? Oh, whatever. Okay, so there we go. So now let's take a look. What does the graph of cosine look like? So I'm going to try to keep the sketch. I'm going to stay zoomed in first. So here we are again. This x is 0 corresponds to 0 radians. So I'm going to go over here to 0 radians. That's the point 1, 0. Now this time though, this is where it gets weird. We're looking not at the y values because we're not doing sine. We're looking at the x values because we're looking at cosine. Cosine is adjacent over hypotenuse, and your radius is always 1. So it's basically just adjacent, or the x value. So I'm looking at the x lengths. So right away, this x length is a length of 1. So at 0 radians, my graph is already at a length of 1. Now I'm going to start to rotate around. This time, look at what's happening to my x lengths, the x side of these triangles. It's getting smaller and smaller and smaller until we reach this height here, 0, 1. Remember, we're looking at cosine this time, so we're only focusing on the x side of the triangle. And in this case, the x side of our triangle has no width, so that's a height of 0. Then we keep rotating. Now look at what's happening to the x length, the adjacent length of these triangles. It's getting larger and larger and larger towards the negatives until it reaches a maximum of -1, or minimum, I should say, I guess. Then we're going to continue to rotate. My x side is fairly long. Then it's getting a little bit shorter, then a little bit shorter until it gets to this spot, which is 0, -1. That's the x number that I'm looking at now. And then my x values again are getting longer and longer and longer until we reach a height of 1. This is one cycle, or one period. That's the phrase I'm going to try to use more and more. That's one period of the cosine graph. And we call it periodic because if we just repeat that again, if we go again or another lap, we're going to get exactly the same shape over and over and over again. So then I would rotate up to 0. I would have an x value of 0. Then I would have an x value of -1. Then I'd have x value of 0. Then I'd have x value of 1. So the sine curve and the cosine curve are actually the same curve. They're just, we call it a phase shift. I'm not going to get into phase shifts, but they're just a 90-degree shift. In other words, if you took this and you shifted it back 90 degrees, you would get exactly this curve. Or if you took this and shifted it forward 90 degrees, you would get exactly this curve. So they're congruent curves, just at different starting values. So how do you sketch these? So you don't have to continually draw all these little triangles in there. All you really need to do is think about the gaps and how those behave. So let's take a look at the sketch of -2 sine of x. So first of all, let's review back to our transformation of functions back in Unit 1. What does a -2 coefficient do to our graphs? The negative means everything's going to reflect, and the 2 means it's going to be a stretch of 2 in the y direction. So everything's going to be twice as tall. So as I rotate around the unit circle and look at sine values, I'm only going to be looking at the y values. I'm going to take those results and multiply them by -2. So let's take a look. So what's the first here? I'm just going to use this as a reference instead of getting out that other unit circle. You could have your unit circle. It's probably easier to look at, but I can't fit both of them on the screen. So 1, 0, I'm doing sine, so that's the y value. The y value is 0. 0 times -2 is still 0. Then I rotate to the next 90. The y value is 1. 1 times negative 2 is negative 2. Rotate, the y value is 0 times negative 2 is 0. Rotate, negative 1 times negative 2 is positive 2. Rotate, 0 times negative 2 is 0. So this is one cycle, one period of my graph. Now you can go back up here and count it again, or you can just slide this over. This translates. So this would be, then it goes down to negative 2, then it goes up to 0, then it goes up to 2, then it goes down to 0. There's the curve. You'll notice a couple of things. So this is the sine curve. So this was a reflected sine curve. And I changed the scale. I didn't put the 2 up there. Probably should have, but this kind of looks, hopefully this looks a little bit taller, but it's definitely at a higher because of, I changed the tick marks to indicate that I had 2 of them. Anyway, let's see if you can handle sketch of negative 1/2 cosine of x. All right, let's see how you did. So I'm going to look at the x values as I rotate around the unit circle, and then I've got a multiplier of negative 1/2. So my graph is going to be reflected, and it's going to be shrunk half as tall. All right, so what's my first? 0x corresponds to 0 radians. My x value is 1. 1 times negative 1/2 would be negative 1/2. Then I rotate up to 90. That's x value of 0 times negative 1/2 is 0. Negative 1 times negative 1/2 is positive 1/2. 0 times negative 1/2 is 0. And then 1 times negative 1/2 is negative 1/2. So here's one period of this graph. You want to connect it all with a smooth curve after you find those points. And then that's going to repeat because this function is periodic. Cosine is a periodic function. One lap around the unit circle is the same as the next lap around the unit circle. Yet again, we've got a reflected, shrunk version of the original parent function cosine. All right, let's take a look at tangent now. So tangent and cotangent. I'm going to do the same thing. I'm going to look at what happens as I rotate around the unit circle. So this time I'm not going to draw the little triangles in between. So for tangent, this is the point 1, 0. This is the point 0, 1. Negative 1, 0. 0, negative 1. Okay, so for tangent, what do we know about tangent? Well, tangent is y over x. So I'm going to take the y value, I'm going to divide it by the x value. So let's start off at x is 0, corresponds to 0 radians. At 0 radians, I have the point 1 comma 0, so y divided by x, 0 divided by 1, 0 divided by 1 is 0. Now, when I rotate up to pi over 2, when I do y divided by x, I get 1 over 0. That's bad news. 1 over 0 is undefined. That's no good. So that's going to turn into an asymptote. So the worst thing that can happen when it comes to a graph is getting 0 on the bottom. That causes the worst thing. The worst thing that can happen in arithmetic is a 0 on the bottom. That translates to the worst thing that can happen in a graph, which is an asymptote. Then I'm going to rotate around now to, so this was 90. This is going to be 180. 180, we do y over x. 0 over negative 1 is 0. Rotate around to 270. Y over x, negative 1 over 0. That's undefined again. Zero divided by 1 is 0. Rotate again. 1 divided by 0, undefined. And you'll start to realize tangent is also a periodic function, but it's a periodic function that has asymptotes. So every one of these 90 degrees switches between a value of 0 and a value of undefined. Now, this is where it gets kind of tough. How do I sketch? How do I figure out where the actual graphs go? Well, you have to look at each quadrant again. Let's look at what tangent is in quadrant 1. If you want to grab your unit circle, You can use this little chart here to help you out, or you can just look at the picture and think about it. In this zone, in this quadrant, x is positive and y is positive. So tangent is y divided by x. So a positive divided by a positive is a positive. That means in this quadrant, tangent is positive. Now that translates, this is between 0 radians and 9 and pi over 2 radians. That corresponds to, this quadrant corresponds to this gap on our graph between 0 and 90, between 0 and 90. So I need to now draw this section of the graph as being positive. Well, if I'm going to draw this being positive and I've got an asymptote, my graph is going to go up towards the asymptote and then get trapped asymptotically running alongside the asymptote. Now let's move to the next quadrant. This quadrant is between 90 and 180. That's the same as between 90 and 180 on my graph. So whatever's happening in this quadrant, I'm going to want to make sure my graph looks the same way when I try to sketch it. So this is where x is negative and y is positive. A negative divided by a positive is going to be negative. That means that this quadrant needs to be negative, so I'm going to draw this one going in the negative direction. Tangent, x is negative, y is negative. They're both negative, so that's positive. And you're probably starting to see the pattern now. My next quadrant, one's negative and one's positive. That's going to make an overall negative. That technically is is not one period. Sorry, this is the length of a period, but this is a one rotation in the world of tangent. Then we're going to repeat that again. I'm going to go up to a positive quadrant. Then I'm going to go to a negative quadrant, then a positive quadrant, then a negative quadrant. Now, when I was a kid, I hated that the graph just stopped right there. If you want to draw the other side to help you understand it better, feel free. That bugged me as a kid, so I'll give you the opportunity that I didn't have. Well, maybe Miss Lentz wouldn't have cared. She probably wouldn't have cared. She was nice. I cared. Anyway, all right, so now let's do the same thing for cotangent. First of all, what can you tell me about cotangent? Cotangent is the reciprocal of tangent. So if tangent is y over x, cotangent is x over y. Let's do our rotations again. So this is 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1. All right, so now we're corresponding 0 on the x to 0 on the radius. Sorry, for radians. And this time we're doing x over y. So right off the bat, when I do cotangent, I'm going to do 1 divided by 0. 1 divided by 0 is bad news. So this graph starts off with an asymptote, where this one started off with a value of 0. Then I rotate up to 90, or pi over 2. That becomes x over y. 0 over 1 is 0. Then we rotate to the next one, x over y. That's negative 1 over 0. Negative 1 over 0 is undefined. It's going to cause an asymptote. X over 0, 0 over negative 1 is 0. And then you can start to see the pattern here. A couple of things to notice as I'm finishing this. Everywhere that tangent had an asymptote is where cotangent has a 0 and vice versa, which makes sense because they're reciprocals. And the reciprocal of 0 is undefined. So everywhere tangent has an asymptote, like at pi over 2, pi over 2 has an asymptote which is undefined, but what's the reciprocal of undefined? That's the value of 0. Okay, now this is where this gets a little bit tricky, so let's take our time and think this through. Let's go through our quadrants again. This quadrant 1 corresponds between 0 and pi over 2, which corresponds over here to 0 pi over 2. This quadrant, which is positive for cotangent, corresponds to these values in here. Then these become negative, these become positive, and those are negative for cotangent. So now let's try to sketch that. So in quadrant 1, between 0 and pi over 2, I want my function values to be positive. So that means that this part of the graph has to be pointed upwards. So it's kind of weird. You go to the point and then you work your way backwards up. Now that wasn't as tricky over here because when we went backwards, it went down and it just feels more natural. But in this case, this section between 0 and 90 needed to be positive. So the only way to do that and hit this point is to start at the point and go up. My next quadrant between pi over 2 and pi needs to be negative, so then these are going to go downward. And then from here, you kind of get the idea. The next one's going to be up. This one's going to be down, and then repeat. What do you think? All right, so we've talked about sine and cosine, the big two. Then we went to tangent and cotangent. Now we're going to talk about the other reciprocal trigs, cosecant and secant. So first of all, let's remember that secant is the reciprocal of who? Sorry, did I say secant? I meant cosecant. Cosecant is the reciprocal of sine. So what I'm going to do is I'm going to take this graph, I'm going to graph all the sine values first, and then I'm going to reciprocal all those values. So let's go through and do sine. Let's see if we can do it off the top of our head. So at 0 radians, the y value is 0. Pi over 2 radians, the y value is 1. Pi, the y value is 0. I'm going back to this without trying to look back at it. I'm trying to just do it in my head. 3 pi over 2, the y value is negative 1. And then 0. 2 pi and 0, the same thing. That's going to then repeat. All right, so right now, who is this the graph of? This is the graph of sine. We don't want to graph sine. We want to graph sine inverse. My bad. Cosecant. Sorry. We want to graph cosecant. That's not the same as sine inverse. My bad. Sine inverse is what undoes sine. Cosecant is the reciprocal of sine. So I'm going to take all of these sine values and I'm going to reciprocal them. For instance, this sine value of 0, when I reciprocal that, what's the reciprocal of 0? Undefined. So this becomes an asymptote. What's the reciprocal of 1? Well, 1 is one of those two weird numbers who are their own reciprocal. So the reciprocal of 1 is still 1. So I'm going to leave that. This has a y value of 0, sine value of 0, reciprocal, undefined. Y value of negative 1, what's the reciprocal of negative 1? Still negative 1. Reciprocal of 0 is undefined. Reciprocal of 1 is 1. Reciprocal of 0, undefined. Reciprocal of negative 1 is negative 1. Reciprocal of 0 is undefined. So what happens is you're going to take all these y values, okay, of sine, and we're going to reciprocal them. They kind of like just get turned inside and out. It's kind of like their guts gets instead of going towards the middle, they go towards the outside of the graph. So think about it this way. When you divide, first of all, these are positive. So when I reciprocal a positive, it's still going to be positive. This is what the sine graph looks like. When I reciprocal a number that's very, very close to 0, I'm going to get a number that's very, very close to infinity. So as you get closer and closer to 0, when I reciprocal that value, I'm going to get a number that's very, very, very large. So this part of the graph ends up going up towards infinity. And instead of going down, this goes up towards infinity. Instead of going towards 0 at the middle, they get reciprocaled and they go towards the infinities on the negative side. That's what I mean by kind of like gets turned inside out. See how these are going in? These go out. This is going in. The sine curve goes towards the middle. But when you reciprocal those values, then they're going to head towards the infinities. And then that repeats. And then that repeats. And there's a sketch of cosecant. All right. Let's see if we can do, why don't you try? Pause and try to do secant on your own. See if you can do secant on your own. Why I take 10 minutes to come up with the colors that I want to use. Let's go with pink and then dark purple. All right, so secant is essentially, it's not essentially, it's the reciprocal of cosine. So I'm going to sketch cosine first. Cosine starts at 1, goes down to 0, goes down to -1, back up to 0, back up to 1, down to 0, -1, 0, 1. Then I'm going to take these values, I'm going to reciprocal them. The reciprocal of 1 is 1. The reciprocal of 0 is undefined. -1's reciprocal is -1. 0 is undefined. 1 is 1. Reciprocal of 0 is undefined. Reciprocal of -1 is -1. Reciprocal of 0 is undefined. And then just like we did in the world of sine, these guts kind of get spilled outward instead of towards the middle. And this is a sketch of secant. Okay, so today we went over all the different trig functions. We did all 6 trig functions. We looked at their parent functions and how to generate them by rotating around the unit circle. Next time we're going to look at how to change the scale. So what happens when we put a different value out in front? We talked a little bit about that when it was sine and cosine. What happens when we multiply by something? That's called the amplitude. And then we're going to talk about how does the period change depending on what you put next to x.